Voroshilovgrad, Soviet Union, in the mid-1930s. They are rolling out a machine that should not exist in any engineering textbook anywhere on the planet. 14. Driving wheels under one frame, 7 coupled axles in a row, a boiler stretched so long it looks like someone took 2 locomotives and welded them together without asking any questions first. The engineers standing around this thing are not smiling because they are proud. They appear convinced they have just beaten the Americans at their own game. See, for years Soviet engineers had been watching what was happening across the Atlantic with a mixture of fascination and wounded pride. Union Pacific had their challengers, the Norfolk and Western had their Class A articulated locomotives, and every time American locomotive builders announced another record-breaking machine, Moscow felt the sting. The whole point of Soviet industrial policy was supposed to be that centralized planning could outperform capitalist chaos. And yet, here were these American railroads casually building some of the most powerful steam locomotives ever constructed, while Soviet shops were still turning out designs that appeared increasingly outdated by comparison. So someone in the planning bureau decided enough was enough, and the directive came down to build something that would make every American locomotive look modest by comparison. And the way they figured it, the path to ultimate power was simple arithmetic. More driving wheels meant more adhesion meant more tractive effort, and more tractive effort meant Soviet supremacy on rails. The math was beautiful. The execution was about to become a catastrophe. The AA-21 rolled out with a 4-14-4 wheel arrangement. That designation had never existed before and would never exist again, and for good reason. To get 7 coupled axles working together, the designers had stretched the rigid wheelbase out to something like 10 meters, which is an absolutely insane distance for any locomotive to cover without articulation. The big boy solved this problem by splitting its driving wheels across 2 separate engine beds that could pivot independently through curves. The AA-21 solved nothing. It just expected the track to cooperate. The first run was a publicity special to Moscow, and according to the reports that survived, it arrived without any major recorded incident. Soviet newspapers probably ran the photographs, party officials probably made speeches, and everyone involved probably thought they had pulled off something historic. What nobody mentioned in those celebratory dispatches was that a publicity run on carefully selected track, with crews stationed every few kilometers to monitor rail conditions, is not the same thing as real railroad operation. The real tests were about to begin, and they were about to go very badly. The problem with 14 driving wheels in a rigid frame is that railroad track is not straight. It curves, it undulates, it shifts under load, and every single one of those movements has to go somewhere. On a properly designed locomotive, the axles have some play, some ability to adjust to variations in the rail. On the AA-21, 7 coupled axles meant that any movement of one wheel assembly was transmitted directly through the coupling rods to every other wheel assembly, and the rails themselves had to absorb whatever the locomotive could not. At approximately 20 tons per axle, rolling over track that was rated for around 78 pounds per yard, the arithmetic that had looked so beautiful on paper started producing some very ugly results on the ground. The switches were among the first casualties. Railroad switches, those movable track sections that let trains change from one line to another, are precision mechanisms that depend on tight tolerances and predictable wheel loads. The AA-21 was reported in post-test technical assessments to have a tendency to damage or destroy switchwork. And that is not exaggeration, but documented engineering criticism. The locomotive would roll through a switch and leave behind bent rails, displaced frog assemblies, and maintenance crews who had to repair the damage before any other traffic could pass. In multiple documented movements, infrastructure damage followed in its wake. The middle axles were supposed to have reduced flanges to help with curve negotiation, a common engineering trick where you let the center wheels float a bit more freely to reduce binding. On the AA-21, this solution proved largely ineffective. The locomotive frequently spread the rails on curves, often forced itself through track geometry that was never designed for anything this long and this heavy, and repeatedly left infrastructure damage behind. Then there was the boiler problem, which becomes almost comical when you step back and look at the whole picture. The AA-21 had 6 cylinders, a highly unusual choice, but the boiler was not sized to reliably supply all 6 under sustained operating conditions. So you had this massive locomotive with 14 driving wheels and 6 cylinders that struggled to maintain steam pressure the moment it was asked to do real work. The couplings between locomotive and tender were reportedly inadequate for the theoretical tractive effort, meaning that even if the boiler had been sufficient, the locomotive could not safely transmit all that power without risking structural failure. The turntables were too short. This is one of those details that reveals how poorly the whole project aligned with existing infrastructure. Soviet rail facilities were built to standardized dimensions, and the AA-21 exceeded those limits by enough that it could not be turned on most existing turntables. A locomotive that cannot be turned is a locomotive that can only operate in very limited circumstances, which severely restricts its usefulness. By the time the testing period concluded, the verdict was comprehensive and devastating. The AA-20-1 had failed at nearly everything a locomotive is supposed to do. It struggled to negotiate standard curves without damaging track. It had a documented tendency to damage switches. It suffered from inadequate steam generation. It could not be turned on standard facilities, and it placed excessive stress on couplings and infrastructure. The locomotive was quietly withdrawn from further development and eventually scrapped. Soviet engineering reports kept the details sparse enough that Western researchers would spend decades piecing together what actually happened. The official Soviet position was likely that the experiment had produced useful data for future designs, the kind of face-saving language every failed engineering project generates, regardless of political system. What the AA-20-1 actually demonstrated was that impressive numbers on paper mean nothing if the underlying engineering cannot support them. 14 driving wheels sound revolutionary until you realize those wheels have to work together on track designed for far less. 6 cylinders sound powerful until you discover the boiler cannot feed them. Record braking length sounds dominant until you find out the turntables cannot accommodate it. The Americans never built anything like the AA-20-1, and that was not because American engineers lacked imagination. It was because American engineers had learned through decades of costly failures that locomotive design is about balance, matching power to adhesion, adhesion to track strength, and all of it to existing infrastructure. The big boy worked because every element was designed to function together. The AA-20-1 failed because it was designed to beat a number rather than move freight. Somewhere in a Soviet archive there are probably photographs of that first publicity run to Moscow, the one that went off without reported problems, the one where everyone smiled and congratulated each other on achieving something historic. Those photographs make an interesting contrast with the maintenance reports that came later, the ones documenting bent rails, damaged switches, spread track, and all the consequences of building a locomotive to impress rather than to function. 14 driving wheels, the only locomotive in history to carry that number, and now you know exactly why nobody ever tried it again.